You know that picture we all have in our heads of how science works? Well, what if I told you that picture is completely wrong? That science isn't some steady, peaceful march toward the truth, but is actually a series of violent, world-shattering revolutions. That's the explosive idea from Thomas Kuhn's landmark book, The Structure of Scientific Revolutions, and today, we're going to tear it all apart.
So let's just ask it straight up. How does science really work? I think for most of us, we imagine it's like building a skyscraper, right? Each generation of scientists carefully adds a new floor, standing on the shoulders of the giants who came before them, building ever upward. But what if that whole image is just a myth?
On the left, that's the story we all get in school. Science is a nice, clean, upward line. We just keep adding facts, and the pile of knowledge gets bigger. Simple. But Thomas Kuhn came along and said, no, that's not it at all. The history of science looks a lot more like the image on the right, these long, calm periods of stability that are suddenly just shattered by radical, game-changing shifts. Okay, so let's dig into those long, peaceful stretches first. Kuhn gave them a name that sounds almost, well, kind of boring. Normal science. And that's actually the point. This is what scientists are doing 99% of the time, just working away, guided by a set of shared beliefs that everyone in their field just accepts as true.
And that set of beliefs, that shared foundation, is the absolute hero of this story, the paradigm. A paradigm is way more than just a theory. It's an entire worldview, usually kicked off by some colossal achievement, like Newton's Principia. You can think of it as the official rulebook for an entire generation of scientists.
Now, here's a crucial idea that might surprise you. During these long periods of normal science, scientists aren't actually trying to make groundbreaking discoveries. They're not looking for something that will turn everything on its head. Instead, Kuhn says they're doing puzzle solving. They're working on problems that the paradigm itself promises can be solved, as long as they're smart enough to figure it out.
And this just shows you how much power a paradigm has. It is the ultimate rule book. I mean, it tells you which questions are even worth asking, which instruments you're allowed to use, and what a correct answer is supposed to look like. It even tells you what the universe is fundamentally made of, whether that's tiny little particles or some mysterious ether. It sets up the whole game.
But, in any game, sometimes a piece just doesn't fit on the board. In science, there are always puzzles that, no matter how hard you try, just refuse to be solved. And these aren't just little oopsies. These are the first signs of real trouble. The first cracks starting to show up in that solid foundation of normal science. Kuhn has a special name for this, an anomaly. It's a result that just completely, totally violates what the paradigm says should happen. Think about the discovery of X-rays. The screen glowed when it wasn't supposed to. An anomaly is basically the universe tapping a scientist on the shoulder and saying, hey, about that rule book of yours, it might be wrong.
Now look, one anomaly on its own, it can be ignored, explained away. But then they start to pile up. And as they do, the scientific community starts to lose faith. That beautiful, elegant paradigm starts to look clunky, patched together, a mess. This is exactly how Copernicus felt about the old model of the solar system. It had so many fixes and exceptions that he called it a monster. And that widespread feeling that the tools are broken, that's what Kuhn calls a crisis.
And a crisis changes everything. All of a sudden, those strict rules of normal science get thrown right out the window. It's a free-for-all. Scientists start proposing all kinds of wild, competing ideas, stuff that would have gotten them laughed out of the room just a few years before. The whole field gets chaotic and argumentative. The foundation isn't just shaking anymore, it's actively crumbling.
And that crumbling leads right to the main event, the climax of our story, the scientific revolution. And let's be super clear here. This isn't just a renovation. This is a complete demolition of the old building and the construction of something totally new in its place.
The key idea here is what Kuhn calls a gestalt switch. A paradigm shift isn't about adding new knowledge on top of the old stuff. It's a total replacement. The new way of seeing things completely overwrites the old way, making it basically irrelevant. It's like a switch flips in the brain of the entire scientific community, and they suddenly see the world in a whole new way.
This famous optical illusion is the perfect way to understand it. Before the revolution, scientists are looking at the data and all they can see is a duck. But after the revolution, they look at the exact same data and now it's a rabbit. And here's the crazy part. They can't even see the duck anymore. The world itself has literally been reconfigured right in front of them.
Let's make this real. Just look at the universe before and after Copernicus.
Before his revolution, the moon was considered a planet. The sun was also a planet, and the Earth, well, it was the unmoving center of everything. But after the revolution, bam! The Earth is now just another planet, the moon becomes a satellite, and the sun is a star at the center of it all. The very identities of these objects completely changed. They weren't just in a different world, they were looking at a different world.
This all leads to one of Kuhn's most radical claims. He says that scientists on opposite sides of a paradigm shift are, for all intents and purposes, living in different worlds. They might use the same words, like planet, but they mean completely different things. They can't just convince each other with facts, because they don't even agree on what the basic facts are. They're talking past each other.
Okay, so if the history of science is really just a series of these massive, disruptive, world-changing breaks, then why haven't we heard this story before? Why does it seem like this history is, well, invisible? Exactly. Why does every single science textbook you've ever read show that nice, neat, upward-sloping line of progress? If revolutions are the main event, where did they all go? Well, according to Kuhn, the revolutions are pretty much erased on purpose. Here's how it happens. First, the winners get to write the history books, right? So textbooks are always written from the point of view of today's winning paradigm. Then, they recast history, making it look like scientists from the past were just working on an earlier version of the problems we're working on today. And finally, the revolution itself just disappears. That messy, chaotic, fundamental break gets smoothed over, making the new way of thinking seem like it was the obvious and logical next step all along.
And that leaves us with this pretty wild final thought from the physicist Max Planck. He's suggesting that big scientific changes don't always happen because of logic and evidence. Sometimes they happen because one generation literally has to die off for a new idea to take hold. It's a powerful reminder of the deeply human, sometimes irrational process behind our greatest achievements. So the next time you hear about a big scientific breakthrough, you have to ask yourself, are they just adding another brick to the wall, or are they about to start a revolution?